Okay, we're still factoring polynomials. So factoring trinomial squares and differences of squares. First you got to learn to recognize trinomial squares, factor trinomial squares, recognize the difference of squares, and factor differences of squares, being careful to factor completely. Now again, if you don't like these shortcut methods, you can do it the old-fashioned way, do it the long way, whatever is easiest for you, but sometimes these are faster when you get higher up in your maths and you need a quick way to factor so that you can move on. So a trinomial square, a trinomial that is the square of a binomial is called a perfect square trinomial. And it looks like this: a squared plus 2ab plus b squared equals a plus b squared. Or you have a squared minus 2ab plus b squared. Remember, the plus or minus is going to always be whatever this term is, and then the last term is always positive. So to recognize perfect squares, reading the right sides first, we see that these equations can be used to factor perfect squares, perfect square trinomials. Note that in order for the trinomial to be the square of a binomial, it must have the following: two terms, a and b, or a squared and b squared, must be squares such as, like 9 is the square root of 3, is 3 squared. X squared is x squared. 100y squared is actually 10y squared. And then 25w squared would be the same as 5w, and then you would square the whole thing. Neither a squared or b squared is being subtracted, and the remaining terms is either 2 times ab or negative 2 times ab. We're going to talk about where the a and the b are the square roots. We're going to work on that. Alright, so this one says to determine whether each of the following is a perfect square nomial. First, can you take the square root of x squared? Yes, that would be x. Can you take the square root of 16? Yes, that would be 4. Now, if I would take the square root x times 4, that's the a and the b, and I multiply that times 2, do I get that middle term, that ax? I do. And if that's the case, you just drop this plus sign in there, put a set of parentheses, and you square it. Now the way to check that is to see x plus 4 times x plus 4, FOIL it. And I'm going to show you what happens. So we get x squared plus 4x plus 4x plus 16. Gather like terms, so you get x squared plus 8x plus 16. So that's how it works. So let's look at these and see if these work. So, is t squared a perfect trinomial? Yes. Is negative 36 a perfect square? Here's why. This can never be negative. Not if you're looking for perfect square trinomials. So this one is not a perfect square trinomial. So we can't factor it the way that we want to. So it's not a perfect square trinomial. Okay. So let's look at this one. What do you notice? The order is wrong, isn't it? Can we rewrite it in descending order? So we get 25x squared minus 20x plus 4. Okay, that helps. Is this a perfect square? Remember, you got to keep the signs too. So 25x squared would be 5x. And what about the square root of 4? That's a 2. Okay? And remember, there's no minus sign before the 25x squared or the 4. And then, so they are squares. Now, if I take 2 times 5x times 2, this is the a and this is the b, do I get negative 20x squared? Or do I get 20x squared? We'll talk about the sign in just a minute. So I do get 20x squared. So by getting 20x squared, we know that the factors of 25x squared minus 20x plus 4 is going to be 5x minus 2 squared. Now let's foil that and double check. 5x minus 2, remember we're writing it down twice. So FOIL gives me 25x squared, gives me negative 10x, negative 10x, positive 10, positive 4, gather like terms, so we get 25x squared minus, I dropped my x right there, minus 20x plus 4, so it does check. Remember, descending order is your friend. Alright, factoring trinomial squares. Again, we're going to do some more. We're going to factor some more. So let's look. Are these perfect squares? Yes, this would be an x, and that would be a 4. Now, if I say x times 4 and put that 2 out front, do I get the 8x that's in the middle? I do. So this is factored. So we get x, remember it keeps this sign right here, plus 4 squared. And you can check it by factoring. Let's look at this one. It's in descending order. This is positive. So the square root of 25x squared is going to be 5x. Okay. And then the 4 is going to be 2. We keep this sign. These are the same problems we did, but this is just the fast way so that you can double check. So 2 times 5x times 2 does equal 20x. So now we know that that's factorable. So now we're going to get 5x minus 2 squared. So see, we did the things that we did earlier. We just did them again, okay? Alright, 16x squared minus 24ab plus 9b squared. Are those perfect squares on the end and not being subtracted? They are. So what's the square root of this one? 4a. Square root of this one is 3b. So if I say 2 times 4a times 3b, 2 times 4a is 8a. 8a times 3b gives us 24ab. So that helps. So we have just figured out what we need to factor. It's going to be 4a minus 3b squared. And if you FOIL it, it does check back. Now, the one thing I have failed to answer is, or ask you is, have we factored out a GCF? The ones that we have been working with did not have a GCF, but this one does. So let's go through and see if we can factor out. So it's going to be a 3a. So now I'm left with 4a squared minus 36a plus 81. Now, we have to look through here and see if we can factor again. So it's a trinomial, so the first thing I'm going to look and see if we have perfect squares. We do. The perfect square of this one would be 2a. Perfect square of this one would be 9. So if I said 2 times 2a times 9, do I get 36a? And I do. So that works. So now we have 3a, and we're going to get 2a minus 9 squared. And we are done. It is factored. Expressions like 25x squared minus 36 can be written in the form of a squared minus b squared. It's called a difference of squares. Note that for a binomial to be a difference of squares, it must have the following. There must be two expressions, both squares. We've talked about this before, and the terms in the binomial must have different signs. That means that this has to be plus and this has to be negative, or vice versa. As long as they have different signs, we can make it work. It's called the difference of squares. So the first slide says to determine if each of the following is a difference of squares, and we're probably going to go ahead and factor them as we go, so it'll make it a whole lot easier. So are these a difference of squares? They have different signs. Is 16x squared a perfect square? It is. The square root is going to be 4x. And 25 has a perfect square of 5. So the way this factors is you're going to get 4x plus 5 and 4x minus 5. Let's pull that back so you can see what happens. It makes the middle terms drop out. So we get 16x squared minus 5x, minus 20x plus 20x minus 25. When you gather like terms, those terms go away, so you wind up with 6x squared minus 25, and you're done. So they have different signs, so that helps. 36, does it have a perfect square? It does. It has a 6. What about y to the 5th? Does it have a perfect square? No, it doesn't. So our answer to this one is not a difference of perfect squares. Okay, let's look at C. Do they have different signs? Yes, that works. Now, is x squared, not squared, x to the 12th, is it a perfect square? It actually is. Anytime that the exponents are even on the variables, they can be considered perfect squares. So this, with the square root of x to the 12th, would be x to the 6th. And then the square root of 49 is 7. So the way that you can write this, you can do it a couple of different ways. You can change the order, because a lot of people would rewrite it to where you would have the sign on the opposite side. So they usually rewrite it as 49 minus x to the 12th. So then you're going to have 7 plus x to the 6th and 7 minus x to the 6th. And then you have to look and see if you can factor any further. We're going to talk about that later. But those are the ones that are factored. Alright, we're going to factor some more. So here's a couple examples. So it's x squared minus 9. They have different signs. They're both perfect squares. The square root of x squared is x. The square root of 9 is 3. So you're going to write it down twice. One's plus, one's minus. Alright, y to the w. Y squared minus 16w. They have different signs. Both are perfect squares. So y is the square root, and then 4w is the square root of 16w squared. So one's plus. I didn't leave myself enough room, but they would be multiplied together. Let's write it smaller so it would work. So we wind up with y plus 4w times y minus 4w. And we're going to close parentheses. We have some more to factor. 25 minus 36a to the 12th. They do factor. But what do you think you need to do first? Is there a GCF? Because I keep forgetting to ask you that. So there's not one here. So we have 5. Don't ask me why I wrote a 2. The square root of 25 is 5. The square root of 36x to the 12th is going to be 6, a to the 6th. So one's going to be plus, and one is going to be minus. Okay, on the next one, do we have a GCF? We do this time. So we have a 2x squared, and we're left with 49 minus 4x to the 6th. Can we factor again? We can. So you get 2x squared. So we get 7 minus 2x to the 3rd times 7 plus 2x to the 3rd. And you are finished. Alright, factoring completely. Sometimes a complete factorization requires 2 or more steps. Factoring is complete when no factor can be factored further. So, we're going to try this one. Step 1, factor out the GCF. So when you take out the GCF, we get a 5. So I'm left with x to the 4th minus 25. So that's a difference of perfect squares. So now I have x squared plus 5 and x squared minus 5. Can we factor any further? I don't see that we can. I think we're done. Any questions? Let's pull this back and see. If we pull this, we get x to the, I dropped my squares, so we get x to the 4th minus 5x plus 5x minus 25. Bring down the 5. These two terms cancel out. So now I get 5 times x to the 4th minus 25. So let's distribute, because we need to distribute. So 5x to the 4th minus, so 5 times 25 is 125. So it did, it checked back out. So we are done. Okay, quick tips for factoring. Always look for a common factor. If there is one, factor it out. Be alert for perfect trinomials and for binomials that are difference of squares. Once recognized, they can be factored without trial and error. Always factor completely and then check by multiplying.